Good. Now that you understand how ionic bonds are formed, we're going to use that information and make compounds, ionic compounds, okay? So don't forget that ionic bonds are formed when electrons are transferred, and specifically, metals transfer those electrons to nonmetals. Okay, so if we take a look at the periodic table again, I'm becoming an expert on drawing this. It's the easiest thing to draw. Hydrogen and helium are in the first energy level, and then we have the second, third, I'm probably not doing it too evenly, fourth, fifth, sixth, and seventh. Okay, now we have two groups. Remember, group 1 has one valence electron. Group 2 has two valence electrons. Group 3, 13 has 3, all the way to 8. 1, 2, 3, 4, 5, 6. Perfect. Now, when we're looking at this, we're going to use the illustration with the electron configuration, but I'm not going to write that every time. What I want to do is I want to use the electron dot. So all of these in this group will have the symbol and then one dot, right? All of these will have the symbol and then two dots because those are the valence electrons for this. This one would have 3 dots. This one would have 4 dots. And remember, we do px, py, pz, and so on and so forth. So let's take a look at some of these elements. We have lithium, we have sodium, we have potassium. I'm going to look at sodium because that's probably the most common one that we use. So sodium has 11 electrons because it has 11 protons. Sodium has 1s2, 2s2, 2p6, 3s1. So it has this one valence electron. So sodium has 1 dot because it has 1 valence electron. Let's say we're going to have it bond with chlorine because that's common. You guys are all used to table salt. Remember, F is fluorine. It's not Florida, FL. It's F for fluorine. Then we have chlorine, bromine, iodine. So we're going to look at chlorine. That one's pretty common. Chlorine has 17 electrons. 1s2, 2s2, 2p6, 3s2, 3p5. 5 electrons. So in the outermost energy level, or the valence shell, so chlorine has 7 valence electrons. Now remember, the magic number is 8. So you see chlorine has a space for another electron right there. Chlorine wants another electron. So if you put sodium and chlorine together, this sodium will contribute its electron so that once this electron is gone, it now has a full valence shell because this one becomes the valence shell because the third energy level now is gone, which makes sodium ions smaller. So sodium gives up that electron to chlorine because chlorine is just one short of a full set. So sodium becomes positive, chlorine becomes negative. Well, how does that work out? Sodium has 11 protons. And 11 electrons. If it gives 1 electron away, it only has 2, 4, 6 makes 10. 10 electrons. So what is the overall charge when it gives that electron away? It's got a 1 plus charge. So we put a little plus up here. It's a superscript to show that it's got a 1 plus charge. Any element that gives electrons, transfers electrons, is called a cation. And the way we remember that is there's a little plus here. So that plus shows that it's positive. So cations are positive. You have a little plus right in its name. Now chlorine has 7 valence electrons already. So it has 17 protons. When it gets this 1, this becomes 6, right? So now it has 18 valence electrons. So it's got 1 extra electron. So it ends up with a -1 charge. And this would be an anion. The way you remember anion is a negative ion. Anion. A negative ion. Anion. So the cation gives its electron to the anion to form this chemical bond. And when we have just one compound, we have one atom of sodium bonding with one atom of Cl, that is called a formula unit. This is not a molecule. A molecule is sharing electrons. This would be a formula unit because compounds that where the metal gives an electron and the nonmetal takes an electron actually form crystal solids. And crystal solids are not like not like molecules. Crystal solids have structure, they have unit cells, so there's a lot involved. So, and the bond between these, the ionic bond, is different than a covalent bond. So they're going to have different properties. Okay, let's try another one. Let's try one from group 2 and group 16. Okay. Again, I'm going to draw the electron configuration, but you don't have to. You can do it just from the electron dot. Just that I just want to show you guys. So I'm going to go with magnesium because that's the next element after sodium. And I'm going to choose oxygen, even though it's right next to fluorine. I could probably choose sulfur, but I'm going to choose oxygen because that's easy, magnesium oxide. So magnesium has 12 valence electrons 12 electrons because it has 12 protons. 1s2, 2s2, 2p6, 3s2. Oxygen has 8 protons, so it has 8 electrons. 1s2, 2s2, 2p4. So as you can see, oxygen has 6 valence electrons, so we're going to do 6 dots. Magnesium has 2, so magnesium is going to get 2 dots. So when we go to draw the compound formula, we have magnesium with 2 electrons. We have oxygen with 6. And this electron will go here, and this electron will go here. So again, this forms an ionic compound because magnesium is happier with this being its valence shell. So it'll get rid of those 2 electrons. It'll give it to whoever is passing by and form an ionic compound. So magnesium is the cation, and oxygen is the anion. Now, when we go to write the name, we always write the cation first and then the anion. So the name of this would be magnesium oxide. Anions change their name. So an anion gets the IDE ending. Why? Because this is a binary compound. So binary ionic compounds, or binary compounds, the anion will get the IDE ending. Okay, what about sodium and chlorine? So we have sodium and chlorine. This sodium is the cation, chlorine is the anion. Cation is always written first. So this would be sodium chloride. Again, chlorine becomes chloride because the anion has the IDE ending. The anion gets the IDE ending. Okay, so it's pretty laid out there. Now, let's think about what happens if we have a group 1 metal with a group 16, like oxygen. I'm going to keep oxygen because it's just easier to do that. All I have to change now is the top one. So I'm going to change this back to sodium. What happens when we have sodium reacting with oxygen? Sodium again is 11, 1s2, 2s2, 2p6, 3s1. Sodium only has 1 dot to give. Right? It's only got 1 valence electron, so it's got 1 dot to give. So I'm going to have sodium with 1 electron, oxygen with 6. Is oxygen complete with just 1 electron? No, it's not. So we're going to need another sodium. So another sodium to give. So our formula for this compound would be Na2O. We need 2 sodium for every oxygen. Same name though. This is still sodium oxide. The exact same name. The name doesn't change. Okay? You're still saying the cation, even though we have two of them. We just say sodium, and then the anion, oxide, sodium oxide. Okay? How do we know we have two sodiums? Because we know each sodium is only a +1, and oxygen is a 2-, right? And we can see that here. Each sodium can only give one. It's not going to give one of these. Why? Because this is complete now. It's only going to give that last one. But oxygen's not satisfied with just one. So oxygen is going to want another sodium to hook up with. All right? Okay, so now let's do this the way that you probably will do it in the future, because I think you guys can do this. You're brilliant. Let us put a group 2 with a group 13, and I'm just making one up, okay? Because I don't even know if this really exists. Magnesium is 2+ because it's in group 2. Phosphorus is 3- because it's in group 15. Okay, so phosphorus is 3- because it's in group 15. And so that means this one has 2 electrons to give. This one wants to take 3. So we have 2 and we have 3. So 1, 2. Phosphorus is not happy. We need another one. Now magnesium is not happy. So we need another phosphorus. Now phosphorus not satisfied, so I need another magnesium. And lo and behold, right? This is magnesium phosphide. Now it's satisfied. And our formula would be Mg3, because we have 3 of these, and P2. It's still called magnesium phosphide. It's still magnesium phosphide. Because I know that it is because of the charges. So I don't have to use anything else to determine it. All right, the other things that the book talked about was the properties, ionic compounds and their properties. You can just list those and memorize it. And then the formula unit. Remember, one compound has 3 atoms of magnesium and 2 atoms of phosphorus. It is called a formula unit. Abbreviated FORM unit, U, if you want to. And it's a formula unit. A formula unit is one compound that is ionic. One compound that is covalent would be a molecule. Okay, but in ionic compounds, they're formula units. All right. So now I hope this helps. If you have any questions, make sure you ask. See you in school.